It's working. It shows me. This is a microphone face. And then we get started. Lemon here, my lemon water. Yeah. I think we on already. Let me just taste it, face and see. Let me check here my phone. Okay, let me tell my familiar here that I'm on so they can come here live and we can get started. Because I'm doing this because of the spatial session that some of the student who requested for me to make this session. Okay, I'm looking for something here. Just a minute. Is it now? Okay, I think it's okay. No problem. I think here can be better. Here can be better. Okay, let me pull this one here because I want to put my microphone very close to me. Oh, sorry, my apologies. I want to put my microphone. I think here is okay. No problem. It's okay here. Okay, so let me just test face and check if everything is fine. Excuse me. Just check him out. People that I'm supposed to have, if they are aware that we have started. Okay, just check them. Check him out. People that I'm supposed to have, if they are aware that we have started. Okay. Let me call this sister here so she knows that we started already. Kamokelo, I'm on already, so just can you hear me? Okay, what I'm saying is I'm on already. Go leave the comments there on the live so I know that you can access the live so I can get started because I do this for you. Okay. Okay, thank you so much. Kamokelo, can you hear me? Oh, okay. Let me send you the link. I understand. Okay, let me send you the link. Oh, okay. Okay, do you have a computer or you have a phone only? No problem. I'm gonna send you the link here, and then just click that link. If you have any questions, so this is what I'm gonna do now. I'm gonna send you the link, and then I want you to comments. You must write the comments to tell me, hey, Tuan, I'm here. Okay, so I know you're right there. Okay, let me send you the link. So you click that link, and then it's gonna take you to the class, to the video, and then right under the video to see that you're there, so that I know you're in the right place. Okay, let me send you now. Okay. Okay, cool. Okay, so let me send her link. She's not too familiar with the social media, so and she said, hey, I'm trying to look. I need a class, So I said, okay, no problem. So let me send to her. Okay, so let me go to Lina Marley. Okay, there's another one, and then Fernando, and then who else? London, okay, another one. Oquanda. And then another one, who else? Okay. Okay, let me just send to them first. Okay, familiar, click the link for okay, I'm trying to keep in touch with my beautiful familiar who's supposed to be here because I'm doing this for them. Okay, so if you're not part of this, just wait there, be patient. They're all gonna come here. We're gonna start very, very soon. Okay, so yeah, let me just ask them. Hey, familiar, you're here. Let me know so we can get started. I'm just waiting for them so we can get started. Yo, she here. She say, yeah, I'm here. All right, so she's here. She's here. Camojelo, she's here. Okay. Oh, Camojelo, she's here. Camojelo, let me know if you can see. Can you see clear? Just read the comments there. So if I know you can see clear, then I can get started. Can you hear me? Tell me I can hear you. I can see clear. Lina Maklausho, she's here. There we go. We're ready to go. I just got my lemon water right here. Ooh, some lemons. Oh, I need to lose some pounds. So I think you guys ready, so we can get started. We don't want to waste your time. Let's get to the business. So we're gonna do this stuff here. So this is more of the assignment which you guys were doing. But before we go to that one, let me explain. Let me introduce you to the integration, because that's the application of integration. Let's go for the face one. Let's go to the face. This one face. Okay. Now let's go to the rules phase. Like I say, phase for you to solve this type of question, you must know the rules, okay? Can you guys tell me, face, if you can hear me clear? So that I know, oh, they can hear me. Leave a comments that say, hey, Mtwana, we can hear you clear. We can see everything's clear there. If it's too small, the number, whatever, you tell me I can maximize, just in case. And if you all can hear, say, hey, Mtwana Wabandu, we can hear you. Huh? So we can just continue. Let me know, because I'm just waiting for you guys. Because yesterday, I had an incident where my microphone, I don't know, it was muted, and then I spent almost 45 minutes and nobody told me. And then later they say, oh, we didn't hear you for the whole session. So I want to make sure if every one of you can hear me clear, and then I can get started. I can start right now. Let me know. Yo, let me know. Let me drink my water. I'm just waiting for you to comment. And then I start. And then I can get started. I can see and hear you. All right. All right. So you all can hear me. Okay. Now, so first and foremost, I want to start with the basic integration. Okay. So let me take you here. But before we do this question, we must know the basic of integration. Integration has a rules. First, oh, what do you mean? I don't even know what is integration meaning. Look, this sign here meaning integration is stand for the integration. But when you write that, for example, if somebody say integral of dx, so these are rules. It's not something say, oh, how did you know? How did you know? Oh my God, how did you know? These are rules, so you memorize. So if somebody give integral of dx, it's the same as say equal to x. So if somebody give integral of L, same equal to L. Integral of dk equal to k. Integral of dm equal to m. If you have a question, if you want me to repeat, you right there. Repeat, and then I'm going to repeat. Oh, I don't understand, and then I'm going to do it again. Okay? Integral of dc equal to c. Integral of dp equal to p. So you have to know that one. Okay? Now, let's take another rule. So just a little rules, little rules, little rules, little rules. Okay? Let's take another rule. Okay, so if somebody give you, let's say integral of let's say x power n dx. So this is more of the power rule of integration. So how are you going to solve this? Look, what you're going to do, don't worry about this dx and don't worry about this integral. You only focus on that. So I'm going to take that one, x power n. See that's one? And then plus 1, make sure you plus 1. And the same thing you write at the bottom. Take all of this right at the bottom. And plus 1 right at the bottom. And then you must plus constant c. What does a constant c mean? Constant c is the constant. And why do we write constant c now? Because there is no limit here. I'm going to show you example when there is a limit, how we're going to do. Okay, that's why we plus constant c. For now, just know I'm going to have to plus constant c. So integral of, let's say, x power, let's say power 4 dx. So how I'm going to say with this one? So then I'm going to say this same as say, like I said, don't worry about dx, don't worry about the integral. Take x power 4 and this small number 4 plus 1. 4 plus 1 equal to 5. And the same thing right at the bottom. Write that 5, only 5 at the bottom. And then you plus c. That's how you do. Let's take more example. So it's easy like this. Like there's nothing complication here. You just follow the rules. Okay, just follow the rules. Okay, let me do like 4 examples, and then we go to the next example. Okay, somebody give, for example, integral x power 8 dx. So then how are you going to say? Only focus on that. So I'm going to say x, 80 plus 1 equal to 9, and then over the same number, 9 at the bottom, and then plus c. That's all you've done already. So what we plus c? Because there is no limit. I'm going to explain to you when there's a limit. You got what I'm saying? Let's take 2 more examples, and then we know we add off here. We add off here. Okay, so somebody give you integral. Okay, before we do that, right? Look, because most of you are beginner here, so you don't know the basic. Okay, if somebody give you integral, so the square root, no square root, x, and here there's a m over n. So from the law of the exponential, this is not integration, this is just normal exponential. So we say this is the same as x, and then flip it, is m over n, right? This is going to be n over m. That's all. So you just flip it. That's the rules. But this is not rules of integration, it's the rules of exponential. So if somebody give me, let's say, square root of 3. So what is 3 meaning? When you say 3, it's like 3 over 1. When you say 3 and 3 over 1 is the same thing, because 3 over 1 equals to 3. So I'm going to say this is equal to x, and then I'm going to flip 1 over 3. You understand what I'm saying? Because of the rules, because of this rule. So if somebody give me, let's say, square root of, let's say, m 4. So what is 4? When you say 4, it's always you say over 1. Put 1 under. So this is going to be equal to m, and then flip is going to be 1 over 4. Okay, I'm going to tell you why we do this. Okay. One more, and then we solve the integral. Now, I'm going to tell you why did I come to that concept right here? For a good reason. Now, I'm going to take you right here, like, why did I come with this concept, my beautiful family? Now, so if somebody give you square root, let's say x. So there's no number. When there's no number, you have to assume the number is 2. Because it's square root. And they say 2 is over 1. So this time I say x, 1 over 2. Now, let's go to the question. Now, you're going to know why did I introduce to this concept? Because some of my... You remember this integration is for beginners, so some people don't know how these basic rules. So, integral, square root of x, and they say dx. So the problem here, we don't have a power. Because like the previous one, it was like integral x power 3, let's say dx, means you take that one with plus 1. But there's no that power right there. So what I'm going to have to remove this square root. So when I remove the square root, look, we know there's no number. When there's no number means this is 2. And they say 2 over 1. So first and foremost, remove that root. So this is going to be same as say square root, integral, and then I'll write only my x, and then I'll say 1 over 2, because I flip this 2 over 1, 1 over 2, and that's a dx. So why do I do this? Because I change it to the power so I can add the number on top. Now, yes, I can integrate because it's already in power. So I'm going to say, I don't need that, I don't need that one. I'm going to say x a half plus 1. And then I'm going to divide by the same thing, a half plus 1. What is a half plus 1? 3 over 2. And this a half plus 1 means what? 3 over 2 also. But look, in math, right? If you have a fraction here, right? If you have a fraction at the bottom, what you do, take this to the top. And then don't write here. Only if you have a fraction. So it's going to become 2 over 3. That's a math rule. Okay, it's going to become 2 over 3. So it's going to become 2x 3 over 2 over 3. More example. More example. More example. Sorry, my apology. My apology. Sorry, there's somebody. One of my other students also. Okay, so let me just close the door. My apology, because okay, so now my apology. I'm sorry. So now let's take more example. So you just have to remember that's exponential, right? How to change the exponential. because it's very, very crucial. Okay, it's very, very important, because otherwise then you won't be able to solve a lot of questions. Okay, let's take more example. Let's somebody give, let's say, square root, and they give you x here and then dx. So first and foremost, I don't need that root. Let me remove the root. So remember, here is going to be 3 over 1. They don't give that 1, but I just say over 1. And then I'm going to say this, let me say integral, and then I'm going to say x, flip it. 3 over 1 means 1 over 3 dx. Now I can integrate because it's already in power rule. So this is going to be equal to, take that, x, 1 over 3 plus 1. What is 1 over 3 plus 1? 1 over 3 plus 1 is, let me say, 4 over 3. But you can plug in the calculator if you don't know. Put in the calculator, it's going to give 4 over 3. And the same thing you're going to write at the bottom. 4 over 3. And then, like I say, if you have a fraction at the bottom, what you do, take this, see this one, take it here, and then don't write here. So I'm not going to write this 3 here, I'm going to write here. Okay? Only if you have a fraction, if you have 2 numbers. But if it's 1 number, don't ever dare do that. So then this final answer, we must plus our c. So then you're going to say, finally, my final answer here is going to be 3 over my 4, and then I'm going to say x, 4 over 3, and then you plus your constant. Okay, so now let's go to the actual 2 more example, and then we can solve that question right here, the question that you see in front of us here. So you cannot solve this question if you don't know the basic of exponential and integration. Okay, you're gonna see I'll be able to solve for you all this question just by taking step by step. Okay, more example. If somebody give you integral of 1 of x power, let's say 3 dx. So now you cannot add by 1. You know why? Because can't you see this is at the bottom now? Is at the bottom. So we must reciprocate. To reciprocate means this stuff must go to the top. Remember, there's no sign here, means it's plus. So to reciprocate means this must go to the top. Because for you to integrate, you remember it was like this. That's a rule how you say. It must be not under. It must be right here. So you see it's under the 1. So we're going to take to the top. You say integral. This process I'm doing is called reciprocation. Reciprocation. So to reciprocate, take to the top. Remember, it's positive 3 here, right? So you write exactly what you have. It's going to be x. But I see it's positive. It's going to become negative 3. It's going to be 1. Okay, it's going to come here next to the 1. It's going to be 1 times x cubed. And then dx. All you need to do, you change this sign because it was positive. When you go to the top, it's going to become negative. So 1 times x power negative 3, just say x power negative 3. So it's like say x integral x power negative 3. And then what we're going to do now, yes, we can apply the rules or the power of integration. So I'm only going to focus on that. So then I'm going to say x power negative 3 plus 1. So x power negative 3 plus 1 is going to be, okay, x power negative 3 plus 1, and then over negative 3 plus 1, because this must be divided top and bottom, plus c. So this, let me say x negative 3 plus 1 equal to negative 2 over negative 3 plus 1 equal to negative 2 plus our constant c. So finally we say, this equal to, okay, look, I'm done solving everything. So that's my final answer, but I'm done already integrate. But look, it's not good to leave your final answer as a negative power. Even though this is we're done already integrate, but it's not proper way to leave your final answer as a negative what? Power. So what we're going to do right here, we're going to say, well, so now I'm going to reciprocate to the bottom. I'm done already integrate, but I'll take it to the bottom because you see it has a negative power. So remember, there's no number here, maybe there's a 1. It's going to be 1 over, at the bottom I have negative 2. Take all this to the bottom, it's going to become x negative 2 to the bottom. But since it goes to the bottom, only thing changes the sign. It's going to become positive 2. Only sign is going to change. And then you plus your constant c. We're done already. Okay, I'm going to do one more example like that, and then we're going to go to our business, to that question right here. So remember that when you integrate, if your x power something at the bottom, make sure you take to the top. But look, these are rules, right? It must look like that, not other ones, which I'm going to show you. Okay, so let's say integral 1, okay, let's say square root of x dx. So you see we got problem face. We don't need the root. We don't need the root. Because look, when you say square root of x, it's same as say x 1 over 2. So first I'm going to remove that x square root. I'll say this is like say x 1 over 2. In the next step, I'll take all this to the top. So I'm going to say integral, go to the top, it's going to be, okay, let's just assume here there's a 4. Let's say there's a 4 here. Let's just say. So it's going to become 4 And this thing is going to go to the top. It's going to become x because it's going to come here. It's going to become x negative a half because the only thing is, if this is positive, when you reciprocate to the top, it's going to become negative a half, and then we have a dx. So the next thing now, yes, we can integrate because already at the top. So we're going to say this equal, first and foremost, this 4 has nothing to do with the integration. It's a constant number. So we're going to take behind. So 4 is going to go behind in the integral, and then write my x negative 1 over 2 dx. So now we can do something with this. We can integrate. And what I'm going to focus on, I'm going to focus on that. So I'm going to say, well, then let me raise here to have a space. And then I'll say, well, so this is, let me say, I'll write my 4, and then I'll say my x negative a half plus 1, because I'm going to say x negative a half plus 1. And then over the same thing, negative a half plus 1 at the bottom. But what's negative a half plus 1? Negative a half plus 1 equal to a half positive. You can plug in the calculator if you want. A half positive. And the same thing I'm going to write at the bottom. 1 over 2, which is the half. So then, let's finalize. So then we're going to say, like I told you before, right? If you have a fraction, only if you have a fraction, right? Take this to the top here. So it's going to become 4 times 2. 4 because it's going to come, this 2 is going to come here. It's going to become like 4 times 2. 4 times 2 equal to 80. So this equal to 18. X power half. And then we left with 1 only here. Plus constant. Well, we add constant because there's no limit. So then we're going to say here finally, this equal to 80. 8 over 1 is just 8. When you say x a half is like a square root of x plus c. Or you can leave as the x a half if you want. So we're done. Now we can do the first question number 1. But just a little thing here. Let me say something here. The last thing. So now there's a little tricky thing here. It's not a little tricky, very, very crucial concept, okay? Like I said, these are rules. For you to solve this question, you must know these rules. Otherwise, if you don't know these rules, then it's going to be a problem for you. You won't be able to solve the question. But we're going to be doing this rule every time, every day. You're going to get used to them, okay? So now, another rule, if you have an integral, 1 over x dx. Look now. Hey, are you going to say you're going to take to the top? Never take to the top. Oh, my apology, right? Okay, never take to the top. Oh, no, it's okay. Never take to the top. I thought maybe my video was frozen. That's why I would say my apology, because every time when I do the session, I also look on my screen here to see if everything's fine. So if you have like this, if it's only x, because remember, if it's power 2 or any power here, we're going to take to the top. If it's power 3 or any number, we take to the top. But this is exceptional case. If it's only 1 power x, you see just x or 1 power x. So this, what you say, this equal to ln. Only if it's 1 over letter, but that letter does not have any power. So we're going to say 1 over x. You're going to 1 over x dx integral. You say ln, and then you write which letter is here, and then you plus c. Only if there's no power here. But if there's a power, then we must take to the top. There's no power right there. Okay? Please, my beautiful family, leave a comment that tell me if you understand first. Tell me, I'm trying to, we understand or we're not, because I'm doing this for you. You know I make this live just because of you. Okay? So, let me know. Leave a comment, say I'm trying to, yeah, we're with you. We're with you. So I know, okay, my beautiful family right here, and are watching the work with me. Okay, now we go. So if somebody give me integral 1 over m dm, this same say ln absolute m plus constant. Why? Because this is just m, no power. Okay, so remember that if it's just only one, okay, or just one more example, the last one, then we're going to be able to solve a lot of questions now, because you know the face rules. So if somebody give you, let's say, integral 4 over x dx. Okay, so they say integral 4 over x dx. So what you're going to do, first and foremost, take that 4, remove that 4. So I'm going to take 4 to the back because 4 is a constant number. So I'm going to say this is the same as the 4. Integral 4 is going to go behind. 4 integral, if you remove 4 here, it's going to be left with 1. It's like a, look. If you remove at the back, it's going to be 1 over x only dx. So then we know this is ln. So then we're going to say we have a 4, it's just a 4. And then when you integrate to 1 over x, it's going to become ln absolute x. And then we plus c. Okay? You must put that absolute like a... absolute means anything which is in front of ln, it must be positive. Let me explain to you what that means. Let me show you here. This is because, let me explain to you why we put absolute in front of the ln. Because, let me put my calculator here. Because look, if you go to the ln, it's not so important, but let me just show you. If you go to the ln here, right? So this is ln. Some people say ln, ln, whatever. It's fine. Never mind me. Ln. Whenever you put ln, the number must be positive. If you put negative, let's say even -1, is going to be error. It's going to say error. My calculator's kind of freeze, okay? See, say error there. So any number when you plug here, when you put ln, it must be positive. If you put negative, any negative number is going to read error. If any number, let's say negative 0.1, let's say negative 0. So let's say 0.5, 0.22. This is going to be, oh, let's just wait my calculator. This is going to read, you know why? Because here 0.2 is still positive, it's not negative. There's no negative sign there. So if you say that, look, it's going to read. It's going to give you answer. It's going to give answer. Sorry, my apologies. I'm eating my lemon water. You see? So if the number in front of the ln, if it's positive number, then it's going to read. But once you put negative, then it's not going to read. This is why whenever you have your ln, you must put this absolute of n. You must put this absolute. Absolute meaning anything when it comes here, when you put absolute, it's going to become as a positive. It's not negative no more. It's like saying if you have an absolute of -3, if you put -3 here, when it comes out of the absolute, it's going to become +3. Remember that. Anything comes out of the absolute is going to become positive. Okay. Now, that one you understand. Look how I'm going to solve this question. Very, very easy now. Let's solve this question right now. Now we can solve this question. We can attack this question very, very quick. So we understand the first rules of integration. Let's solve this question now. Look how easy it's going to be, this question. Okay, they say integrate all of this stuff. So I can integrate one by one. Or I can simply say, okay, I'm going to say integral. And then I'm going to put integral of all of this stuff dx. Integral of all of this. Okay, let me put like this. Okay, sorry. Because they say integrate. You remember whenever you integrate, you must put with the dx, dm, it depends on the letter. So let me put this stuff in a bracket. I'm going to say bracket, and then I'm going to say, let me put my integrals. I'm going to say integral of all of them. You know, when you put brackets, like everything. Oh, let me move my calculator. I'm sorry. You guys must let me know if you don't see something. Sorry. Let me move my calculator aside. Yes, like this. So I put my bracket like that. And this is an integral. And then I'll say what? Dx. I does not want to write from outside there, but I think you can see, right? Okay, let me write here. So I'm going to say integral of 100 x 99 plus 20 x power 4 plus 3. Oh, no, plus what? Plus 2 over x plus 2 over x squared plus 3 over x plus 9 dx. Stuff like that. So integrate all of them. That's what I put bracket. It means all of them we must integrate. So we have to integrate one by one. Let's start one by one. So I'm going to start the integral of the first one, which is 100 x power 99 and then dx with the dx. Let's integrate that one. So first and foremost, 100 is a constant. So I'm going to take 100 outside. So this 100 is going to go out here. Let's take 100 out. So I'm going to let you, because it went out here, behind, or behind the front, whatever you can call it, x9, 9 dx. Oh, so now we can integrate this one, because now I only want to focus on this one here. So then I can say 100 is just 100. And then I'm going to say I don't need that one. I don't need that one. Integral dx, I don't need. I'm going to say x 99 plus 1 equal to 100. And then over the same number, what? 100. And then we plus c. But hey, look. 100 and 100 is going to cancel. So it's just say x 100. So when I integrate the first one, it's going to be x 100. But remember, I'm not done, because I must do this one, must do this one, must do that. So I'm not going to plus c now. Until when I finish all of them, I'm only going to write one c. So it's going to be x power 100. That's our answer for the first one. So for the first one, it's going to be x 100. So if you integrate this, it's going to give us what? X 100. Plus, let's say plus. Now we go for the next one. So for the next one, it's going to be integral 20, 20x power 4. But I can take 20 behind. 20 behind is going to become x power 4 dx. Familiar. This is very easy. Let me go quicker. So 20, just say 20, x. 4 plus 1 equal to 5, and they're divided by the same number at the bottom, 5. Plus c. But like I said, I'm not going to plus c now. I'm going to plus c later. But if you take 20 divided by 5, 20 divided by 5 equal to 4. So this let me say 4 x power 5. So remember there's a plus here. I'm going to say plus what? 4 x power 5. So long you can see all of them is like same thing, x power 100. Let's continue. You can see in the options like all of them is like it go the same flow. Okay, now we're going to go for integral 2. So this 2 is constant, so I'm going to take 2 out. If I take 2 out here, I'm going to be left with the 1 over x squared. But hey, look, I told you, right? If you have something like that, what you have to do, take to the top. Because remember, you're not going to say this is long because there's a power here. So we must take to the top. We must reciprocate. So then we're going to say this, let me say 2 integral x. But remember, this is a plus. When you go to the top, it's going to become what? Negative 2 dx. So then we can do the same game. We say this is equal to 2 is just a 2 xx. Negative 2 plus 1 equal to negative 1. And then you over the same thing, negative 1 plus c. But let's not plus c now because it's still continue with our mission. Now, 2 divided by negative 1 equal to negative 2. So we're going to have a negative 2. And then we have an x negative 1. X negative 1. So I can live like that if I want. But I can simplify further. Because that's correct. But let me simplify further. I can reciprocate this even though it's my final answer. But I can do something about it because I can reciprocate this. So I'm going to write my negative 2 and then take this to the bottom because I don't need to have my answer with a negative power. So it's going to become here at the bottom. But this negative 1, right, it's going to become positive 1. But when you say 2 power positive 1, it's let me say 2. When you say 4 power positive 1, it means equal to 4 power 1 equal to 4. So this let me say negative 2 over x. So answer negative 2 over x. And now you already see, you start to have an idea. Already the answer is going to be A or B. Already you can see that. Answer is A or B. Negative 2 over x. So for the third one, it's going to be negative 2 over x. Now we want to go for the third one. So the third one we can see, we say integral. Take 3 to the back, 3. 1, because this 3 went behind here, 1 over x. And then we have a dx. Oh, this is the one with the loan. Ha 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 ha. That's the one with the loan. Huh? Huh? So this is going to be 3. Lina Mas, are you here? Yeah, Lina Mas, I see her. Yeah, I see her. I see her right there. So we're going to say 3, 3. But all this stuff here, because Lina Mas told me like, I know you can't give me that distinction. I need that distinction. So let's work on 100. So I'm going to say my 3, 3. But when you integrate 1 over x, it's going to be ln over x. You write your absolute, and then you write whatever you have here. Why? Because this is just x. It doesn't have any power. If it had a power, we have to reciprocate. So 3 ln of x. So there's a plus here, there's a plus. And then 3 ln of x. So we keep going. So this all so long same and this so long same. Now let's go to the next one. So the answer is going to be A or B, but let's just go. So it's more of the rules. There's no magic here, right? There's no magic here. Okay. Now we want to go for 9x. So it's like integral of 9. But when you integrate, you must have a dx. But remember, 9 is going to go to the back. And there's going to be integral of dx. But remember, I told you before when you started, when you integrate, d integral d linamahle equal to d linamahle. When you integrate, kamogelo, d kamogelo equal to kamogelo. So when you integrate dx, integral of dx is same as say 9 times d is going to be x. 9x. Excuse me, sorry. So this is true and this is true. But I'm gonna go for the first one because remember, when you integrate, you must plus constant. So the first option is a true. Second option is not true because they did not plus the constant. And we know these are wrong, all of these. Because this is not true, it's not true. Because remember, there's a 2 over x. There's no 2 over x, there's no 2. So the answer is option 1 because you have to plus constant. Any question, please let me know. If you want me to repeat, let me know. Or we can move. We can move to other question. Let me know. Let me know, my beautiful family. Okay? Kamokelo, right there. Elina Matle, talk to me. You know I'm here because of you. Let me know. Because I do this for you. You asked me to make a video for this. Now, let me know. Let me know right there. Leave a comment. Let me know. So we can get down to it. Or I can repeat or we can move to the next question. Susan. My mouth is kind of dry a little bit. So I'm going to go next page. But leave a comment there. Let me know if you with me and you understand. Okay. Let's take a question right here. I'm with you. We can move. I'm with you. Okay. So let me show you something integration, but with a limit. Let's take integration, but with a limit. For example, if somebody give you, let's say integral 0 to 1. Oh, before we go there, let me show you another rules of integration first. Let somebody give you integral f of x dx. Integral of x dx, okay? This is another student who also do the same things. Oh, she says send me the link. Which links you want to send you already? You need to click the link. Come on, I'm sorry, my apology. Where is she at? She come now. No kwanda. That link I sent you already a long time. You're just supposed to click that link and watch. You're gonna see us with live. What are you doing? Okay. Click that link, you're gonna see me live, and then you're gonna see us with live, and then write the comments there, okay? Okay. Yes. Come on. Guys, no wonder is kind of disappointing us a little bit. Come on. Everybody's here. Where you at? Go.
Issues connecting. Issues connecting. My devices are just acting up.
Okay. Just click that link. It's gonna take you in straight, and then write the comments so that you know you're in there. Say, hey, ndigunokwanda ngap. Yabona. Yeah. Nokwanda. Go click that link. Click that link and then write the comments, okay? Thank you. I apologize, my beautiful family. That's our other family member, so she kinda, I don't know what happened to her. She was maybe forgot or she don't know how to. So yeah. Okay, so let's just wait for Nokwanda because she's coming now in a second, so we know she's here. Nokwanda, let us know if you're here. Write the comments. So, because these are new rules now I want to explain, so you know you're not missing nothing. Okay. Let me just go ahead because we don't know how long she's gonna take, or she can just watch video later because we can't just wait for forever. So now, according to the rule for integration, this is same as say, look, check this out. If you are given integration e f of x can be anything. For now, just know this. Say 1 over, and then take this function here right at the bottom. But you must derivate. I'm gonna explain how you're gonna do that. And then write exactly what you have here, which is e f of x plus your constant c. That's all. Let's take more example. So if somebody give me integral e f of m dm, you know now you deal with a dm. So I'm going to say 1 over, write my f of m here, but you must derivate. And then write exactly what you have, only e f of m. You plus constant c. Nokwanda, let me just make sure if Nokwanda's here, so she's not going to miss out because I'm starting something new now, so I don't want her to miss out. Nokwanda, if is here, please leave a comment so we know you're here. Leave a comment, please leave a comment so I know you're right here, okay? Because I only see 3 of us. We're watching, means me and my other beautiful familiar here. Nokwanda, she's not here yet. Okay, let me just call her. We're sure that she's here or not. If it's not, then we'll move because we can't wait for forever. Oh. I apologize. I was not meant to call you. I'm sorry. I'm in a live class. I just called you by mistake, but I'll come and attend you. Let me call Nokwanda quick. Oh, she's not there. What is happening? Oh, she's here. I apologize. Okay, she's here. She's back. Okay, now let's go ahead and continue. But let's go ahead and continue. So, okay, I'm gonna repeat this rule so she's not gonna miss out again, Nokwanda, because this is a new rule now. We've been explaining all the rules, but she missed it now. Okay. So rules of integration. Other rules, because we did other rules already. My beautiful family. Come on. Let me just put here because people be constantly. Okay. So if somebody give you integral E, let's say f of x dx. So this let me say 1 over, take this one right here, right at the bottom. And then what you do, you see exactly right, and then you must derivate it. You put dash. And then after that, write exactly. I'm sorry. I'm sorry. Okay, I was just playing my own video right there, just making noise. So then we say, so take this one, say 1 over, write this function at the bottom, then derivate, and then write exactly, which is going to be E f of x. And then you plus constant. Let me say it again, one more time. Because I know Nokwanda, she just came now, so she might not understand what is happening. So this, let me say 1 over, take your function here at the top, and then write exactly, but what you have to derivate and then write your E, and then write exactly as you have here. And then you plus constant. Why? Because we don't have a limit. For example, right? Let's take an actual example now, how we do that. We want to go to the actual example. Actually, a vivid example. So somebody give you, for example, integral of E x squared dx. How are we going to do that? It's easy. What you're going to say, you say 1 over, take this function derivate. But when you derivate, or you can just say like this is x squared, but we must derivate. And then write this exactly, ex squared. But hey, look, when you derivate x squared, this meaning derivate, this sign is like derivate. When you derivate x squared, look, what you do, you take this 2 to the back. So I'm going to write my 2, and then write my x, whichever number is here on top, minus 1. 2 minus 1 equal to 1. So instead of this stuff here, I'm going to write 2 power. I'm going to say this is equal to 2x. 2x power 1 is like 2x. So this is going to be my final answer. But a 1 times e power square, I don't have to write 1. So like say 1 times e power x square is like e power x square. So finally, like I said, this is like e x square over 2x. Okay, 2 more example. Let's check 2 more example. And then we can go to the question here because I want to show you how to get the area under the graph. Okay. For example, somebody give you e, let's say x power 4, let's say 2, let's say power 7 dx. So the rules are the same. What I'm gonna do, I'm gonna say this is 1 over, and then I have to derivate this, and then write to the final at the bottom. Or I can simply say, well, is 2x power 7, and then all of this I must derivate, and then write exactly what we have here, which is e, and then 2x power 7. I don't have to write dx, I don't have to write integral, that falls away. So this you may say, but you must plus your constant c because there's no limit. So then I'm going to say, when you derivate this, let's derivate the side. So it's going to be 7 times 2 equal to 14. Write your x, and then you say 7. 7 minus 1 equal to 6. So 14x power 6. Okay? So then I'm going to say, well, I don't have to write this no more. 14x power 6, I'll write my 14 x power 6, and I'm done already. But a 1 times anything, it just does something. It's like 1 times a equal to a. 1 pen is 1 pen. So simple, I can say e 2x power 7 over 14x power 6, and then you plus your c. Done. You see what I'm saying? Nokwanda say, oh, my network is terrible, I apologize. It's okay. It's okay. Apology accepted. Apology accepted. Lina Mantley, she's been sitting there quiet. Lina Mantley, you're sleeping. I can see you right there. I can see you sleeping, Lina Mantley. because I know how you are. If you here, I know you was gonna say something. Renando, I don't know where he is. Camojelo, are you there? Camojelo, let me know if you're right here. Okay, now let's do something with a limit right now. For example, if somebody now with the limit, because I explained everything with the limit, but I did not show you the example how to do with the limit. For example, somebody give you, say this is 0 to 1, and then let's say e power x dx. They give you limit right now. So now if they give you limit, you're not gonna plus c. So this MSA. So first and foremost, don't bother about the limit. Let's get to the business. So this MSA, look. If you see e power sum, how I'm gonna say? I'm gonna say 1 over derivate whatever I have here. So I'm gonna say x derivate, and then I'm gonna write how I have here, e power x. But I don't ever know where I cannot sleep. Do you see how she? Let's give her 5 minutes. I'm telling she's gonna sleep right now. Okay. So then we say we're gonna. Now you're not gonna plus c. You know why you're not gonna plus c? Because you have a limit. Only when you don't have a limit is when you don't plus c. So I'm gonna say 0, and then we're gonna say power 1. 0 and 1. So then let's derivate x. When you derivate x equal to 1, because you know why? Let me explain to you what that means. X power 1. Let's derivate. Remember, you're gonna take this to the back. So it's gonna become 1. Write your x, but whichever number you have here, we must minus 1 always. So 1 minus 1 equal to 0. But any number power 0 equal to 1. This stuff equal to 1. X power 0 equal to 1. So it's like 1 times 1 equal to 1. So when you derivate all of this equal to 1. Or you can simply say this. Look, anything power 0 equal to 1. Remember that. Let me show you in a calculator quick. If, for example, if you, oh, my apologies, sorry. If you have any number, let's say, oh, my apologies, I'm sorry. Anything power 0, let's say, press 0 there. And they say any number power 0. So any number, you can press any number, even 1 trillion, any number. And then just go to the power and they say 0. Look what we got here. 1. It's going to come as a 1. Oh, so anything power 0 equal to 1, we have proved it. Oh, yes, it is equal to 1. So that's what I say here. Oh, okay. That's what I say here. This x power 0 equal to 1. So it's like a 1 times 1 equal to 1. Okay? So when you derivate x power 1, we know equal to 1. Like over 1. So now I'm going to say 1 over 1 is just a 1. So I don't have to write anything because like 1 over 1 times whatever we have equal to that. So whatever we have. Okay? So I don't have to write 1 over 1 no more. So my final answer is going to be e power x. And then my limit is 0 to 1. My limit starts from 0 to 1. So now, here, right here, listen to me careful, right here. Now, what you always have to say, you say upper limit minus lower limit always. Upper limit minus lower limit always. Okay, what is upper limit? Upper limit is 1. So you substitute that limit whenever there's an x. Whenever there's an x, you substitute the limit. So this upper limit is going to come here. So I'm going to say e. Instead of this x, because up, I'm going to replace you there with the upper limit. And then you must minus by lower limit. So lower limit means I must use small number. I mean the number at the bottom. So this number at the bottom is going to come in a position of x. So I'm going to say minus e. So this 0 is going to go there. It's going to become 0. So this time is say e power 1 is just e minus, but we know anything power 0 equal to 1. So all this stuff power 0 equal to 1. So it's e power 1. Now let's get to our business now. Let's get to our business right now. Let's get to our business, to the actual business. Let's come here. I saw here that interesting question. This one here. Area under the curve. Find the area under the curve. Area under the curve. Area between, area under the curve. What does that mean? You might have a curve like this. Let's say this Cartesian plane. And you have a certain graph. Let's say you have a graph here. Let's call this f of x. But hey, look. Here, at the x-axis, what the value of y? Y equal to 0. Everywhere here, the value of y equal to 0. Means our y always equal to 0. So area under the curve, always, you say integral means, okay, let me just say like this. let's say our area under the curve from, let's say, x equal to a to x equal to b. So we want this area here. Let me use, okay, I mean this area here from x equal to a to x equal to b. So I'm going to say area under the curve. This is the application of integration. So then I'm going to say this. Let me say you write your lower limit a. What is the upper limit? Upper limit is b. And then you take upper function, the function which is on top, minus the function at the bottom. Which is the function on top? Is this one here. You minus the function at the bottom. But the function at the bottom, we know this is the line which is at the bottom, which is enclosed between this and the y-axis. And at x-axis, my apology. But right here, the value of y equal to 0. So you can say minus 0, and they say dx. For now, okay, not all the time minus 0. I'm going to show you more example. So that's how you get the area under the curve. Take upper graph minus lower graph, and then your limit is going to be where the graph is starting to where it's finished. That's how you get the area under the curve. Let me show more example, and then we get to the question. Not like more example solving is a diagram. So if somebody give you, for example, let's say integral, graph, sorry, my apologies, I was meant to say graph. Yeah, I'm addicted to it. Oh, my microphone just fell. I apologize. I'm sorry. Hello. I hope you can hear me. Okay, I want to make sure I'm just checking. I hope you can hear me because my microphone kind of fallen on the floor. I apologize. Okay, so if you have this Cartesian plane, now let's say something like this now. So you see now, this is different case now. So this is like, let's say this is x1 and this is x2. So the area enclosed between x1 to x2 of the two graphs, let's say this is f of x, and let's call this g of x. So we're going to say area enclosed equal to lower limit. I hope you can hear me. If you don't hear me, guys, my beautiful family, leave a comment that say, we cannot hear you since your microphone fell, or we hear you, we with you, okay? So we're going to say integral. What is the lower limit? X1 for now. Upper limit is x2. And then you take the upper graph minus the lower graph. The top graph minus the bottom. Do not do other way around. You're going to be in trouble. Because like I told you, math is the rules and you have to follow the rules. So I'm going to say upper graph, which is f of x, minus the one at the bottom, which is g of x. And then you're going to say dx. That's all. Now let's go to this question right here, which they gave to us right now. Let's solve now. They say find the area between the curve. So it's like we don't have another curve, it's only one curve. So it means the other curve is going to be at the y-axis, at the x-axis, I mean. I'll show you what I mean. So I'm not going to draw all this curve here because it's going to be wasting a lot of time, but I can just show you how we can do. So we're going to say now area equal to integral. Do you have a limit? They say on the x-axis from 0 to 1. So what that mean? Means I'm going to say my limit is going to be from 0 to 1. It's like, let's say roughly, right? We don't know how the other curve it is. I'm just saying, for example, something like that. So this is going to be start from 0. They start from 0 to 1. It's 1 here. So this is not actual curve, right? I'm just assuming. Because they don't want you to draw the curve, whatever. I'm just saying, okay? Just assumption. So it's going to be like this, let's say 0 to 1. So this is the upper graph, which we know is that one, minus what? Minus, start from 0, which is lower limit to upper limit what? 1. So our top graph is going to be this one, which is that one, but it's not actual. I'm just assuming because the multiple choice. So you don't want to waste a lot of time, start to draw the graph and how my graph look like. Unless if they say draw, then you can do it, which I can draw for you. But for now, let's get to the business and solve what they ask us to do. Because you have to be strategize. I'm not a native English speaker, right? So never judge me. I'm a mathematics speakers. Okay? So then we're going to say our lower limit. Our lower limit equal to 0. Upper limit equal to 1. Oh, okay. Let me write lower letter because it's like I write on top there. Area equal to integral. What is the lower limit? 0. Upper limit equal to 1 because they say from 0 to 1. And then we're going to take this upper function minus the lower function is here. But this point here, y equal to 0. Means we are not, because they say between the curve. So it's going to be that graph, however you can draw it, minus this graph is lying on the x-axis, but anything lying on x-axis, y equal to 0. So we're going to say all of this, which is 3x power square plus 5 e5x plus 2x plus 13. We minus, okay, let me just erase here, because since we know y power 0. Because the other graph lie on x-axis. Like I show you the rough sketch, okay? Okay? Minus 0. And then all this together, dx. But a minus 0, I don't need this minus 0, because anything minus 0 just does something. So I don't need that. Because 1 minus 0, 1. 3 minus 0, so you get the same thing. So for that being said, I have to integrate this. Let's integrate one by one. Or we can integrate all of them together. Area under the curve equal to, let's integrate one by one. Let's start to the face. So I'm saying integral 3x squared. Let me take my 3 outside and then write my x squared and then dx. So what happened here? There's going to be 3. So we know this is a power rule of integration. So I'm going to add by 1. According to the rule, I'm going to say x. You take this power, you add by 1. 2 plus 1 equal to 3. Over the same thing right at the bottom. But hey, look. 3 and 3 cancel. So just x power 3. So for the first one, it's going to be x power 3. You see what I'm saying? Let's go for the next one. So for the next integral, which is 5e power 5x. Okay, so integral of this one here, which is 5. So I can take the 5 behind because 5 is constant. So I'm going to be dealing with the e 5x dx. So according to the rule of exponent, I just show you now recently, what you're going to be doing here, because it's e power something. So I'm going to write my 5 is just a constant, and then we're going to we must derivate this. So I'm going to say I must take 5e, or 5x, my apologies, that power. You must take everything on top of e, and then you must derivate, because according to the rules, when you integrate e power function, you must take your function to the bottom and you must derivate. And then we'll write the way how it is, which is e 5x. So now let's derivate 5x power 1. No, it's just a 5x, sorry, it's just 5x. And then we must derivate. This sign means derivate. Look, so how are we going to derivate? Look, when you derivate 5x, but remember there's no power here. What does x means? Which power is here? Means is 1. So it's like power 1. Now, 1 times 5 equal to 5, write your x. Now take this 1 minus 1 equal to 0. So this is like 5 times 1, because x power 0 equal to 1. So just say 1. So 5 times 1 equal to 5. So all the things when you derivate, it's going to give you what? 5. Equal to 5. Oh, so some apology. So this is going to give us what? 5. 5 and 5 cancel. So this is e 5x. So for the second one is e 5x. So for the first one, e 5x plus e 5x. So we want to go for that. So is integral of 2x dx. Remember, 2 is going to go to the back because 2 is constant. So I'm going to write my 2 here. But remember, there's no power here, means it's power 1. So we have to use the power rule of integration. Power rule of integration, what we do, we only focus on this because the power rule is x power 1. So I'm going to say my 2x, take this 1 plus 1. 1 plus 1 equals 2 over your 2. And then what happened? This and this cancel. So is x squared. So this is going to say plus or x squared. Now we left you the last one, which is 13, integral of 13. And remember, we're not going to plus the limit here. We're not going to plus c because we have a limit. So I'm going to say integral of 13 dx. So 13 is going to go to the back, 13, and then integral of dx. But integral of dx equal to x. Integral of dm equal to m. Oh, we know that story. Come on now, please. Integral of dx, according to the rule, equal to x. You memorize that one. Those are rules. Integral of dk equal to k. Integral of mtwana equal integral of d mtwana equal to mtwana. So then this equal to 13x. So here it's going to become plus is plus 13x. But hey, remember, we got our limit here 0 to 1. So I'm going to say my limit is 0 to 1. So now is the time to substitute the limit. Upper limit minus lower limit. Let me erase everywhere so I can have a space here. Because we want to substitute our limits in proper way. In a proper way, we don't want to trouble. Now, so according to the law of limit, we say upper limit always, or upper limit minus lower limit. Upper limit minus lower limit. What is the upper limit? Upper limit is 1. So whenever there's an x, I'm going to substitute 1. So I'm going to say my area equal upper limit. Where there's an x, I'm going to substitute 1. 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 Okay, now we go. So here's going to be 1. 1 power 3 is going to be 1. Because like a 1 cube equal to 1. We plus. So this is going to be e 5 times 1, because this is going to be 1. 5 times 1 equal to, it's going to become e, because like 5 times 1 is like e power 5. So e power 5. Let's go to the next one. Plus, for upper limit now, until you finish upper limit. Now you come for here, this one is going to come here. It's going to become like a 1, because x, and then square. What is 1 square? 1 square equal to 1. So we're going to plus what? 1. We go for the next one, for the last one, actually 13. So the last one is going to be 13. X. So 13x is like 13 times 1. So 13 times 1. What is 13 times 1? 13 times 1 equals 13. Because we're going to say 13. Because 13x. 13 times 1 equals 13. So we're going to plus 13. Now we're going to go for the lower limit. Because according to say upper limit minus lower limit. So we're going to say minus. Let's go to the lower limit. The lower limit is 0. So we're going to substitute 0 here. So we're going to say 0 power cube. What is 0 power cube? Is 0. So I don't have to write anything here. Now we go plus. E. So here it's going to become 5 times 0, because this is going to be 0 now. 5 times 0 equal to 0. Because it's E 5 times 0. But this 5 times 0, just say 0. 5 times 0 equals 0. So E power 0. But any number power 0 equal to 1 means everything equal to 1. So we're going to say 1. So I can simply write 1. So this is 0, we know, because when you substitute 0, 0 cube is 0, and this is going to be plus 1. Now we come here plus. If you substitute 0 here, it's going to become 0, because 0 square equal to 0. Now we come here plus 13 times 0 equal to 0. So all here on the right hand side is just a 1. I believe so, just a 1. So we're going to say 1. But there's no answer there. Means I made a mistake somewhere. Okay, wait. Yeah, the is. Sorry. Yeah, the is. I see the answer. So then we're going to say the easy answer. My apologies. I'm just thinking far ahead. Okay, now we go. So now we can just do normal addition. A equal to 1 plus 1 plus 13 equal to 15. Plus e power 5 minus 1. 15 minus 1 equal to 14. So area equal to 14 plus e power 5. And we're done with that one, which is going to be this one, e 14. Okay, let's take another question here. Okay. Do you move forward? Talk to me, my family. Talk to me. And another things, hit the like button. Just click the like button. So I know everyone click the like button and then leave a comment space. So I know we continue. We go ahead and I solve another question, or you fine for today. Click the like button so we know we can move forward, and then let me know if I should continue to solve more questions. I think I should, because I'm left with few questions here. So we know we can always do everything afresh again. Okay. Let's take more application questions here, because I don't think it's good to start, because I can just finish them for the next 15 minutes. Okay. Now we have a question right here. Excuse me, sorry. We have a question right here. They say integrate this one. Let me do another one first. Now come. This is easy. Let me do this one. This is value tracing. Application of integration. So let's say suppose the marginal revenue. Okay, let me explain to you something. If you have a marginal revenue, okay, and then you want to get total revenue, okay. If you have a marginal revenue, for you to get, okay, let me say it like this. Sorry. because they say find, don't worry about whatever they say there. They want you to find total revenue. And what did they give? They say suppose you have a marginal revenue, M at a marginal revenue, and they say find the total revenue. So total revenue equal to integral of marginal revenue. That's all. Integrate marginal revenue is going to give you total revenue. That's all. Simple as that. Now let's go. So since they asked for the total revenue, don't worry about the rest of the number. Let's integrate the marginal revenue. Because if I integrate my marginal revenue, it's going to give me total revenue. Now let's see how we can do that. So then I'm going to say total revenue I'm looking for equal to integral. Do you have a limit? No limit right now. We don't have no limit. So I'm going to say my 300 minus 13 q squared plus 16 q cubed. And the bracket here, remember, is going to be dq because you deal with a q. So this, remember, you integrated what? The marginal revenue. The marginal revenue is this one. That's why right here, this is my marginal revenue. And then dq because this has to do with a q. So if I integrate that, and then I'm done. So then we're going to say our total revenue equal. So let's integrate one by one. Now let me start with the first one. Integral of 300 dq. So 300 is just a constant, so it's going to go to the back. So I'm going to left with the integral of dq. What is the integral of dq? Integral of dq equal to q. Integral of dp equal to p. Integral of dx equal to x. So integral of dq equal to q. Simple like that. So then I'm going to say this, let me say 300 q because all this stuff equal to q. So for the first one, if I integrate the first one, it's going to be 300 q. Let's go for integral of the second one. Let's finish up everything today. We don't want to leave anything here. Integral of negative 13q squared. So negative 13q, okay, let me write exactly so you can see negative 13 q 12 d. Remember, you must put dq. So negative 13 right to the back. So I'm gonna, okay, let me just integrate here because there's a space here. Negative 13 right to the back because just a constant, has nothing to do with the integration. Is a constant integral. Now q square dq. So what happened now? I'm gonna say this equal to negative 13. Write your q. 12 plus 1 equal to 13 over the same thing. 13 means you take this, you plus 1. 13 over 13. Power rule. Okay, if you were here from beginning, they should understand this part. Okay. Remember, we can cancel some here. 13 divided by negative 13 is going to be negative 1. So this, let me say negative q power cube. Okay. So negative q cube. Negative q power 13, my apology. Because this 13, my apology. 13. Negative q power 13. Negative q power 13. We have to finish this today. Negative q power 13. Negative q power 13. Let's go for the next one. So for the last one, 16q cubed. So I'll take 16 out because it's a constant, and then integral of q cube dq. So this, let me say 16 is just 16, and they'll say q 3 plus 1 equal to 4, and then we over 4. Okay, by 4, 1, how many 4 in 16? 4. It's like a 4 q power 4. It's going to become plus, it's just a plus 4 q power 4. So we're done. But remember, you must plus constant. You must plus. Why? Because there's no limit right there. No limit. No limit. So for that being said now, and then they mentioned something, but they said the revenue of selling units, okay, the total revenue from selling is, so this is a constant. 3316 is constant. So instead of the C, I'm going to write 3316 because they say there, find the total revenue function, which is here we got. They mentioned something here. The revenue from, okay, they say the total revenue from selling from selling is unit is that one, 3316. So instead of say 6, I'm going to put that constant, which is 3316. So for me personal, I'm going to go for the option number 1. I personal, I would do like that. But hey, you can tell me your opinion. At the end of the day, we can learn from each other. Because this is constant. Instead of say C, I'm going to say that one. Because they say it's a constant. They didn't tell you it's a constant, but they tell you in a indirect way. So that can be the answer. It seems, okay, look. My beautiful family, you want me to continue? So this is going to be option number 1. Always tap here. Please leave a comment, let me know. Because I'm doing this for you. Right here. No kwanda kamogelo. No kwanda kamogelo. No kwanda kamogelo. And Fernando. And everybody who's here. Let me say everybody. No kwanda kamogelo. Pezwa. Asilela gapa. And then what else here? Yeah. I can see you right. Okay, let me know. You want me to continue? And do more question, please let me know, my beautiful family. I'm going to drink my water and then you let me know. Let me know. The answer is not C. Oh, yeah, C. I'm sorry, C. Thank you so much. Come on, hello, thank you. The answer is C. I was wrong. The answer is C. The answer is C, and I'm sorry. I apologize. Thank you. That shows a lot that you follow up. And I apologize. The answer is C. I'm sorry. I'm very, very sorry. I apologize. The answer is C. She's right. She's very right. The answer is C. I was very, very wrong. Co-accuracy. And I was wrong. See that? Come on. Now, you tell me now. So you tell me, my beautiful family. No kwanda. I'm not seeing you right there. Okay? Everybody. Kamogelo no kwanda. Kezwa. Everybody, please. Let me know. You want me to continue? I can continue. I still got energy. You let me always stop here for today. And then we can do tomorrow again. Talk to me, my beautiful family. I'm just waiting for you to tell me if you want me to continue. We stop here. Let me know. I'm just waiting for your feedback. So we know we stop here, we continue. Linamahla. Talk to me. Last one, please. Oh, so you want me to do last one? Okay, no problem. Let's get to the last one. Then one last one. Then one last one. That's good. So check this out. Okay, you see now they give you something. So once you have a marginal, and then you look for the total, what you do, integrate. Excuse me. So now look, they give you marginal. We can continue tomorrow. So no, talk to me. Oh, it's fine. What you guys say? Should I? Let me do one more. Since Kamogelo wanna continue, let me do one more. No kwanda, we can you namadla. Okay, is namadla. Can't we continue tomorrow, please? Let me do one more. No. Let's just do one more. We can repeat it. One more. 5 minutes. 3 minutes. I'll be done. Find marginal cost of a good. So they ask you for the marginal. Excuse me, sorry. They give you marginal and they ask you to find total. Oh, so once they give you marginal, they ask you to find total. What you do, integrate. So for me to get total cost, it does not matter total whatever. Total cost equal to integral of marginal cost. That's all. So I'm going to say total cost equal to integral. What is my marginal cost? That one. Negative 10 q power 4 plus 3. Oh, I wrote very up on point. Let me write down a little bit because I wrote on top behind my page. So once they give you marginal, they ask you to find total of anything. It could be total, whatever. So now I'm going to say my total cost equal to integral of the marginal. Always integrate marginal to get total. Marginal cost. So I'm going to say my total cost, which we're looking for, integral of my marginal. What is my marginal? Negative 10 q power 4 plus 3 q plus 18 q. but a DQ, because now it's about D, is about Q. But if it's about M, you say DM. So now we go. So now let me just do straight away, because now you guys know how we can solve this. This negative 10 is going to be constant. I'll do straight away now. Integral, look, integral negative 10 Q squared. So take negative 10 out, Q power 4. So let me do shortcut, because since it's going to be negative 10, just negative 10. Q power 4 is going to become Q, 4 plus 1 equal to 5, and then we over 5. But a negative 10 divided by 5 equal to negative 2. So it's like saying negative 2, this and this, by 5, 1, by 5, there 2. So negative 2, Q power 5. So we're going to say this equal to negative 2, Q power 5, plus. Now let's go for the next one. I'm going to do in shortcut way. So this, let me say, 3, just a 3. Now Q square, because we integrate, integral of Q square. So this, let me say, 3 square plus 1 equal to cube, and then we divide by 3. This and this cancel, so Q power 3 plus, this is going to be power 1, remember. So we're only going to write our 80, because we integrate this, right? Our 80 at the back. When you integrate Q power 1, it's going to become Q, 1 plus 1 equal to 2, and then over 2. But 80 divided by 2 equal to 40. So I don't have to write 8 over 2, I just say, well, 40. But remember, you must plus your constant here. But what is a constant? If you can look careful here, right? Look to the question. They say, oh, the fixed cost of production is 1,000. So that's a fixed, is a constant 1,000. So I don't have to write C. I can simply say, I don't have to write C. I'm going to write 1,000. I don't have to write C. I write my 1,000. So let's go to the option. If I can look quick, the option is number C. Is option C. I'm not going to make the same mistake, because Hamogelo was very, very careful. Negative 2Q squared plus Q cube. Yeah, I think we can start here for today. So what I'm going to do, I'm going to call you on Skype so I can have a feedback, okay, on how we did and how we can go about it. Thanks a lot for your time. And hey, look, if you're new, we have another class and other people, just in case if you don't know, we have a program where we give back to the community and helping the homeless. You see what I'm saying? We helping the homeless, man, so they can send their own tool features files, giving them knowledge, tag, especially children who are homeless or dropping out. You can't believe in 2022, there are children who have never attended school for the whole entire life. They're 15, 14 years old. So what I do in my program, taking these kids and enroll them in a formal education, and sometimes giving some, knowledge, power of the knowledge, so they can be independent, help themselves in their family, in their community, and they can change their whole life. You know what I'm saying? So they can have the skills, also equip them with the skills. So if you want to see something like that, click the link below and you can see what I do for the community. So I have a link under this video. You see what I do for the community. See what I'm saying? So for that being said, for this live, we stop here. Okay? For more video on what I do for the community, like I say, as far as helping the homeless, uplift the community, feeding program, giving back knowledge, food, the little that we have, the link is below. Okay, so what I'm going to do, I'm going to call you via Skype. This live here, I'm going to end, I'm going to stop. Before we stop, please click the like button, my beautiful family. Everybody who watching here, click the like button and we stop here. And I'm going to call you on Skype. Thanks a lot. And I appreciate it. Don't forget to click the like button. Thank you and peace. We out.